practice C has to do with electric power. Now we see that power is equal to the voltage times the current. So this is one of our equations for power. Power is equal to VI. But yesterday we also learned Ohm's law that V is equal to IR. Okay, that's Ohm's law. Now, what if I took this and I substituted it in here for V? So now I would have power, and instead of V, I have IR times I. So then I see that power is also equal to I squared times R. Now, what if I take this equation and I have power is equal to I squared R, and I also know from Ohm's law that I is equal to V over R. So what if now I substitute this in here? So I have power is equal to V over R squared times R. So power is equal to V squared R squared times R. And then this cancels with that. So I also have that power is equal to V squared over R. So what you see is I have three different equations for power. Are they all the same power? Yeah. But the difference is that they all have different givens. So what you might want to realize is if I'm given V and I, and then I have my power equation, if I'm given V and I, the equation for power is equal to VI. If I'm given I and R, the power equation is power is equal to I squared R. And if I'm given V and R, the power equation is power is equal to V squared over R. Now, you could derive all of these equations using Ohm's law like I just did, and just remember P is equal to VI and derive them, or you could just memorize them like this. Okay? Either way you want to do it, it's up to you. But when we do tonight's homework, the point is that in every problem there's different things that are given. So even though they're all involve power and there's only 5 problems, it depends on what's given. All right, so let's look at, I guess, problem number 1. And for me, a lot of times it's nice to see something like this. So now you see it all makes a lot of sense. Instead of just memorizing, well, where did this come from? It's from using Ohm's law. Now, let's say you don't remember all the equations. Just remember you take your basic equation, and then you can just substitute in the other variables from Ohm's law to find the other equation. All right, number 1. So number 1 says a 10,050 watt electric toaster. So we're given, remember, watts is a measure of power, so the power is equal to 1,050 watts. Operates on a household circuit of 120 volts, so V is equal to 120 volts. And it says, what is the resistance of the wire that makes up the heating element of the toaster? So I want to find R. So now I want to find an equation that has P, V, and R in it, because I have P, I have V, and I want to find R. So I want an equation that has those 3 variables. So now if I look, so basically when I look here, which is the one that has V and R? Well, it's this one. So that's how I know. That's why I want to use that equation. So V, well, I'll write it in its basic form. P is equal to V squared over R. but I want to find for R. So I'm going to rearrange the equation to solve for the unknown in terms of the known. So R is equal to V squared over P. So it's equal to 120 volts squared over 1050 watts. And then on my calculator, $120 squared divided by 1050, and that comes out to be 13.7. And then if I put in correct significant figures, let's say 14 ohms. And that's it.